in superheated state. Steam lies in superheated state, right? So now open superheated steam tables. Open superheated steam tables, right? Open steam tables, superheated steam tables. So find out at 1.4 megapascal, or it may be the 14 bar, comma, where you can find the two things only, that is 350 degrees centigrade is given. Corresponding to that one, you have to note down the specific volume. It is 0.2003 meter cubed per kg, and H value is 3149.5 kilojoule per kg, and S value is given as, from the steam table, it is 7.1360 kilojoule per kg Kelvin, right? Next, the another it is a thing, it is given as but 400 is mentioned in the steam table. You cannot find 380, right? So for this case, again you have to note down these values. It is 0.2178 meter cubed per kg, and H is 3257.5 kilojoules per kg. Units will be same. S is 7.3026 kilojoule per kg Kelvin. So the units will be same. Now here the job is that you need to find out at 380 degrees centigrade. You need to find out at 380 degree centigrade, right? At 380 degree centigrade. So for that case, you can use the linear interpolation formula. That is, you can use the linear interpolation. Linear interpolation, one same word, in linear interpolation technique. Linear interpolation technique. So what is that linear interpolation technique? So this is what you have to find, that is y minus x, sorry, it is y minus y1. So it is y, you have to find y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. x2 minus x1. So when you draw the plot here, and this is the y and this is the x, and the linear interpolation will be like this one. So first, initially locate the point 1, that is y value and x value. Locate the point 2, that is y value and x2 value. So this is x1, this is x2, this is x2. Now at any location, so here, say suppose if you want to find out this particular case. Now here, what are the two things are given? What are the two things are given? That is, here 350 and 400 degrees centigrade is given. So y2 is given, y1 is given, y2 is given, y1 is given, x2 is given, x1 is also given, x1 is also given, right? So related to that one, say suppose if you want to find out the volume, if you want to find out the volume at 380 degrees centigrade. So apply this particular methodology is connected to the volume side, connected to the volume side. So whatever the temperatures are given, and whatever the pressures are given, then which one you have to find out, so always the known values onto the x-axis, unknown values will be onto the y-axis. So this is the technique. Known values will be onto the x-axis, unknown values onto the y-axis, right? So the known value, say suppose if you take this one as 380, right? And x1 is 350, and y you have to find, and this y1 is nothing but equal to see, this is the temperature, 380 minus 350, and at 350 what is the specific volume? So in the same way, the specific volume things are given, y2 minus y1 divided by x2 minus x1. So you can get the value from this particular case as, try to check it out, 0.2108. It is meter cube per kg. That means here the value must lie in between these two. Now the answer, check the answer, 0.2108. So 0.2108. So exactly it is going to lies in between the two things, right? So this is the linear interpolation technique you can apply in order to make the calculation for this particular cases. So like that one, you can find out the enthalpy. And I tell you the another procedure, that here whenever you know the enthalpy, see here the enthalpy at I will tell you the another procedure. At 350 it is given as 3149.5 kilojoule per kg, right? And at 400 degrees centigrade from superheated steam table use, that is because already superheated steam, right? So at 400 degrees centigrade the value is 3257.5 units will be same. Now what you have to do, you have to make the calculation at 380 degrees centigrade. So that 380 degrees centigrade, the value must lie in between the two things. So on this particular point of view, then how you are going to find out, that is enthalpy at 380 degrees centigrade. So this is your target at 380 degrees centigrade. So that means the enthalpy at 400 degrees centigrade minus enthalpy at 350 degrees centigrade divided by the temperatures. See here, the temperatures, what are that one? 400 minus 350, right? So this is the temperatures are okay. Then 380 minus 350. 80 minus 350. So this temperature terms getting cancelled, then you can get the value at this side. So that is here when you do this particular task. So here it is 3257.5 minus enthalpy at this case 3149.5 divided by 50 into 30. So you will get one numerical value. After getting that numerical value, then you have to do plus to this value, whatever the value you can get it, or you have to do minus to this one, so that you can get the value at this particular case. So at 380 degrees centigrade, the value which you can get is 3214.3. Now you can observe the value at 380 degrees centigrade, you will get the 3214, that is kilojoule per kg. That is kilojoule per kg. So this is how, because here the initial step is finding whether the steam lies in the saturated state or the steam lies in the superheated state. So that a student has to identify. Once that is when a given saturation temperature or the saturation temperature is less than the, when the saturation temperature is less than the T given temperature. So here the given temperature is 380 degrees centigrade and the saturation temperature is around less than. So it lies in the superheated state, and in the superheated state where you can find the value as 350 and 400, but you need to find out at 380 degrees centigrade, and based on that one you have to make the calculation, and finally the solution will be the answer for this enthalpy at this. So in the same way try to make it work it out for the entropy. So the entropy at 380 degrees centigrade, what you will get is the answer I am going to write. It is a 7.2360 kilojoule per kg Kelvin, right? So this is how the things you have to make the calculation. Next, moving on to the another problem. So here a vessel, that is a vessel of volume 0.03 meter cubed contains a mixture of saturated water, that is liquid, saturated steam at a temperature of 250 degrees centigrade. The mass of the liquid present is 9 kg. Find the pressure, mass, specific volume, enthalpy, entropy, and the internal energy. So how you are going to solve this particular case? So try to observe this one, right? Now getting the values here. So here, what is that specific volume? The at 250 degrees centigrade. So at 250 degrees centigrade, the saturation pressure value is 3.973 megapascal from the steam table. So corresponding to this one, you try to get the value of Vf and Vg. The same way, try to get the value of Hf, Hg from the steam tables, and if possible, also record the HFG, SF, SG, SFG, right? This is what you have to make. Now, here, volume of the liquid, so that is capital V, is equal to mass of the liquid into specific volume of the liquid. So this is in kg, this is in meter cubed per kg, kg cancelling. Then what are the units for mass of the? So it is meter cube. So that you have to work it out. So when you work it out, it is a 9. Vf value is 0.0012512. So the answer for this volume of the liquid is 0.01126 meter cube. So in the same way, try to get the volume of the vapor or volume of the gas. So the total volume is 0.04. So total volume minus this one, right? Minus this total volume. So it is 0.04 total volume minus Vf, that is 0.01126. We will get that value as 0.02874. 0.02874 meter cubed, this value. So now you have got the Vf and Vg which are in meter cubed. Then from this case you can also find out mass of the gas. That mass of the gas is equal to Vg divided by small vg. So that you have to observe, right? So small vg value from the steam tables, it is 0.05013. So if you make the calculation for this case, then you will get it as 0.575 kg, 0.575 kg. So total mass, the total mass is equal to mass of the liquid plus mass of the gas. Mass of the liquid plus mass of the gas. So you will get as total it is 9.575, right? 9.575 kg, right? So once you will get the mass, then you can find out the quality of steam. So that is mass of the gas divided by total mass, this one, right? So you can get the quality of steam as 0.06. Then immediately you can find the specific volume, because they have asked to find the pressure, it is found, mass is also found, the specific volume. Now you have to find, that is Vf is equal to Vf plus X into Vfg. If you make the calculation for this case, you can get 0.00418 meter cubed per kg. Then enthalpy Hf plus X into Hfg. So you will get that value as 1188.32 kilojoule per kg. Then S is equal to Sf plus X SFG. So that value is 2.9895 kilojoule per kg Kelvin. Kilojoule per kg Kelvin. So this is how you have to make the calculation. And next, in enthalpy is over. And next one is internal energy. So that internal energy U is equal to H minus PV. H minus PV, right? H minus PV. So what is the H value? That H value is 1188.32 minus the pressure is the saturation pressure is 3.9. So 3.97 into 10 to the power of 3, because it is in mega. So try to convert that into the kilojoules, that is Kelvin. And V, what is the V? So this is the V. So it is 0.00418. So the answer here it is 1171.72 kilojoule per kg. So this is how the answers are there, right? So that is what the thing, right? Now moving on to the another case. So here steam initially at 0.3 megapascal. Steam initially at 0.3 megapascal, 250 degrees centigrade, is cooled at constant volume. Is cooled at constant volume. At what temperature will the steam become the saturated vapor? Will become the saturated vapor. What is the quality at 80 degree centigrade? Then what is the heat transferred per kg of steam in cooling from 250 degree centigrade to 280 degree centigrade? 280 degree centigrade. So for this case, first you have to draw the pure substance, that is a PV plane. Once if you can draw the PV plane, then it is very easy to find out. Then the constant temperature line onto the PV plane, the constant temperature lines will be of this one. The constant temperature lines will be of this one. So try to observe this particular thing. So these are the constant temperature line. Constant temperature line. So first initially 0.3 bar is mentioned, 0.3 megapascal. So the pressure is equal to 0.3 megapascal. That is nothing but equal to 3 bar. So from the 3 bar, the saturation temperature